webinar, JMX Get the Most Out of This Unsung Hero. Today's speaker is Tom Lubinski, President and CTO of SL Corporation. Tom founded SL Corporation in 1983 and is currently the company's President and CTO. He has been instrumental in developing SL's graphical modeling system software and the more recent RTView software. Prior to starting SL Corporation, he attended the California Institute of Technology and developed a substantial consulting practice specializing in object-oriented programming and graphical visualization systems. He has over 30 years of experience in the development of computer hardware systems and software applications. Throughout the event, please feel free to submit your questions in the panel located at the right-hand side of your screen. We'll answer as many as possible after the presentation. Now it's my pleasure to introduce Tom.
Yeah, hi there. Thank you, Gia. So today's presentation is focused around JMX, and it's an area that a lot of people have forgotten about, and yet a very important area that we find in our business. I mean, our business is centered around monitoring and keeping infrastructure running, and we, as a company, SL Corporation provides tools. I'm sure most of the people on this call are already aware of SL Corporation and our RTView products, so I'm not going to spend any time on that. I will say that we have encountered many different sources of data that are available for monitoring your infrastructure and your application servers and all the components that your applications are based on. And a common thread runs through all of them. That's JMX. And one of the things that I have always been intrigued by is how to get better use out of JMX, because it really is, as we say here, it's an unsung hero. I mean, if you look at the application servers that are out there, every single one of them exposes data from JMX. People are looking for solutions, ways to monitor their applications more efficiently and better, and yet there are very good lessons and some very good techniques and practices available in JMX. So that's going to be the focus of today's presentation. Now, I'd like to make this interactive if possible, so if anybody has any questions, feel free to forward those, and I'm happy to interrupt and address some of those during the presentation. So let's just take a look here. So one of the first things that I would talk about here is, why would you even care about JMX? One of the important things here that we find in our business is that monitoring is very, very critical for complex applications. Many businesses today, their entire business is dependent on their applications remaining online and healthy, and you've got to have some way of monitoring it. Now, monitoring has been around for ages. The question is, do you really want to go creating something from scratch when there are many patterns and tools available to you out there already? We have found that JMX actually is a really good model for presenting monitoring data from your applications. And we're going to show you here some of the reasons why we believe that to be the case. So where did JMX come from? Basically, the need for collecting monitoring information a decade or two ago. JMX has its roots in agent technology. In fact, we deal a lot with TIBCO. And TIBCO has a product called Hawk. It's an agent that monitors the TIBCO infrastructure. A lot of the concepts in JMX are very similar to what was in TIBCO Hawk, and in fact, form the basis for some of the specifications. JMX has been through a couple of iterations, 1.1, and then there's a 1.2 version. And when Java 1.4 became available, it was basically an external add-on to Java. So if you had Java applications, you could bolt on JMX. But in 1.5 and beyond, which is the last 4 or 5 years, we have had JMX automatically available in Java, which makes it very easy to use. So one reason why you would use JMX or even consider JMX is standards. I mean, people want to develop things that are standard. Other new employees could learn how to use it quickly. It can be compatible with other systems. There's many JMX monitoring tools out there. If you can standardize your monitoring and management, then you can take advantage of all the different tools that are available out there. The other thing that I really like about it is that it defines a standard system-independent way to pass data around, and this is the area we're going to focus on. There's also a standard naming and access mechanism, which is very useful. So we find in our customers a couple different approaches to monitoring. One of them, which is probably one of the most common, is they don't monitor at all until after the fact. They certainly don't design monitoring into their applications. After problems occur, then they go searching for ways to do it. Now, many applications output log files. Sometimes they write data to a database. Sometimes they send JMS messages. These are all means of exporting information about how your application is doing. Sometimes there's TCP or web service transports used. The thing is, JMX provides a way to make it easy and standard, and in fact is compatible with all these others. That's what I want to talk about today, how we accomplish that. So JMX, out of the box, automatically gives you, about your Java applications, a whole series of data sets. There's half a dozen different data sets that you get out of the box. Gives you information about your operating system, your threads, your CPU, your heap size, and with the right tools, like RTView, for example, you can attach to the JMX server and populate some history database and draw trend charts and so on of that data. So out of the box, you automatically get information about your applications without doing anything custom. All you need is a tool to tap into it and see what's going on. Other examples, Tomcat. This is a page from a monitoring system that shows you the Tomcat data. And you can see that every one of the individual servlets on this Tomcat system is producing information about expired sessions, total sessions, processing time, and here again, trend charts. So it's very easy to get that information about JVMs and also about some of the standard application servers that are out there. Where can you take advantage of JMX data? Well, this is a typical application model that we encounter. Many users have applications that exist in these three basic tiers. So at the bottom, you have your hardware, your OS, and you have your middleware, you have your application tier. And many applications nowadays are based on these three tiers. And we find that JMX is especially useful in this middleware area, that most of the application servers automatically expose JMX data. You just need to take advantage of it. And then at the application level, your individual application components, often custom apps, can be instrumented with JMX. Now, this is where the challenge comes from. A lot of people don't know how easy it is to use JMX, and so they fail to instrument their apps. And in reality, it's so simple that that's what I mean. It's an unsung capability that you could be taking advantage of. So the question is, how can you get your apps to produce data just like Tomcat and other middleware components do? Well, the first thing you have to do is learn how to use JMX. The key, though, is using it in the right way. What is the right way? Well, the first thing is you have to understand that JMX can give you this abstract definition of a monitoring model, and this is very important. It's a simple data model. You want to use the simple model. There's a lot of complexity in JMX, which is one of the things that scares people away. In my experience, I highly recommend sticking with the simple form of JMX and not going and using some of the more complicated mechanisms. We'll talk about some of that as we go down the road. The other thing is that JMX as an abstract model doesn't require that you expose the JMX data through a JMX transport mechanism. You can use any transport mechanism, and that's one of the things I want to discuss today is some of the ways that you can transport the JMX data in other ways. So let's talk first about an abstract monitoring model. First of all, monitoring is observing your application. Management, on the other hand, is commanding, and JMX really does both. But the key in making it a truly effective model and being able to use it and reuse it and not complicate your application is to isolate the monitoring and management code from your application code. The communication to your application should be one way. The application shouldn't know it's being monitored at all. Right? So here's an example. Here's a picture. The monitoring code should look at the application, but the application shouldn't know, really, that it's being monitored. It's being observed. So basically, the monitoring code observes the internal structures, executes commands in your application code, but the application has no idea. And often those internal data structures and the commands are already there. There's already an API to expose them. The monitoring code is the standard mechanism for transporting it out to the world in order to be monitored. So there's only one requirement, really, to use JMX. The application has to indicate that it is observable and then set up the observer. Now, modularity is very important. The more you can organize from the start, the better off you'll be in developing a JMX monitoring application. The more data structures you have, the more complexity. Okay? I'm going to emphasize simplicity over and over again. So typically, an application consists of global application data and data about various components that are being instanced within your application. Now, the monitoring code, the way we like to organize monitoring code, if you think this way, you can structure your monitoring code to mirror the structure of the application. And basically what you need is an agent, a JMX agent. You need some kind of a manager around the whole application, and then you need a manager around each individual component. This is a conceptual model that we have found very, very useful. And if you think this way, you can build monitoring code to monitor your application in a way that is manageable and maintainable. So I've provided here some sample code. I'm not going to go into all the details about this. This code will be available on our website if you want to get a hold of it. But this is just simple code. And you can see here that the only thing that the application has to do is to basically create that JMX agent. Okay? And that's how it basically indicates that it's being observed. And then in that JMX agent that you produce, then you simply define these are the two constructs that are needed to communicate with the JMX mechanism inside of every Java application. You automatically get a JMX server built into every Java application if you enable it, and this is the way you enable it. So you create a platform MBean server, and then you instance the sample app manager. And the sample app manager's job is to observe the app or to manage it. You can also execute commands. So this is a modular organization for your JMX code. Now, what we're recommending here, the reason we're providing this to you, is that many people don't know where to begin. And the recommendation here is that this structure for the JMX code that you have to attach to your application can be dropped into any application and almost immediately start to become useful to you. So basically, in this sample app manager, we are pointing to the application, as you can see at the top, and then we're basically making the reference to the app when you instance it, and then we identify individual MBeans. This is the mechanism by which JMX identifies MBeans. So this code, as I said, you just drop this code in, and then you can start building your monitoring. So that's basically, that's all there is to it. Now, what you want to do is you want to maintain a very simple data model if possible. And you want to make the monitoring data easy to consume. So far we've talked about how to very quickly set up a JMX monitoring app, but then you want to make sure that you keep it simple. And the reason for this is that most of the JMX monitoring tools that are out there are actually fairly simplistic, and many of them have trouble consuming the complex data structures that you can create in JMX. And so what we're saying here is you want to avoid complex data structures. Keep it simple. You want to make your data self-contained. You want to identify in the data itself, the tables of data that you return from JMX, identify where it's coming from. These are a couple of key concepts in a simple data model. Now, JMX provides 7 basic data types: int, longs, doubles, floats, booleans, string, date. Now, there are other data types as well, but in our experience, these are the ones that can be consumed by most of the products that are available to monitor JMX. And if you limit yourself to these 7 data types, then you're in good shape. Now, you can, here's some example code where, let's say that you've got these global application variables, and see this is code from your application, and you've got global data that you want to monitor, and these are the data types that we would then be able to consume or monitor with JMX. This is the code that is put in place to monitor those variables. So what we've provided here is a simple template for any of the 7 data types. This is the simple code that is implemented in your Manager MBean in order to access those data types. And here's the interface. Basically, in a JMX app, you have an interface and you have a manager module, and the interface is the way JMX sees what the data is that you have available. By simply including this interface and that app manager code, JMX automatically can see what's going on in your application. And so in JConsole, this is what you would see. Over here you can see those 7 variables that we had of the different types. And as you click, so we haven't done anything except added that code to your application without modifying the application at all. We're just looking at the app, and then you can see those variables within your JMX, within JConsole. Now, you can also look at it in products like RTView, and one of the advantages of products like that sometimes is that you can aggregate all these up into a single table of data. This is one of the things we do with RTView is we aggregate these up, and so you can collect multiple variables into a single table. And here's examples of each of those 7 different types. There are some other useful data types, but they need to be used with care. And you have an array, you have composite data, and tabular data. And these are the more complex data structures. Now, our recommendation here is to use them with care because in the case of an array, for example, RTView and other products, as well as JConsole, it's not that hard. An array is easy. Okay, here's just an example of a string array, and here's how we present it in RTView, and JConsole also can look at it in a similar fashion. Okay, and this is what it would look like, the code that you would use in order to access it. Okay, so in the App Manager, we just have a reference to it with this type of structure. Now, composite data, though, is where it starts getting interesting. People like to use composite and tabular data because it gives you a table of data consisting of multiple text fields. And here's the code. Now, the problem is we generally don't recommend using this. Many developers like to use composites, but the problem is most JMX clients cannot parse that data very easily. RTView can see it, but JConsole can't. JConsole can only view one element in the composite at a time, just like most other JMX tools. So we find a lot of composite data being used in some of the app server, MBeans, and it takes special coding. You have to actually write special code to parse out those composite data structures. We recommend against using it. Now, tabular data is a slightly different beast. Tabular data is a little bit higher level construct which uses composite data. The tabular data structure consists of multiple composites. Now, this one actually is recommended for use when performance is an issue for you. The advantage of this, because it consists of multiple composite rows, you can return hundreds or thousands of rows at once in a single table, and it's a much more efficient transfer mechanism for the data from JMX. And so that's where you would actually use it in the cases where performance is an issue. It's a little bit more work to use by clients, but in this case the trade-off is sometimes worth it. So the alternative is to use multiple instances of a single MBean, but that's more costly. RTView is able to see tabular data easily, but again, JConsole can only view one element at a time. However, the advantages of tabular data are such in terms of performance that it could be worth it if you have an application that has a lot of monitoring data. So we ran into a case here with Oracle Coherence. It's one of the products that we have a standard monitoring module for, the distributed caching system. And in this example, there's hundreds of nodes, individual JVMs. A node is a JVM, and each JVM is managing 50 caches in a typical scenario. And what they do in Coherence is they put each cache on each node into a separate MBean, 5,000 MBeans. And one of the things that we did in our package around Coherence is we wrapped that 5,000 MBeans. We built a custom version of an MBean, which wrapped it into 100 tabular data MBeans, each with 50 rows in it. So instead of transferring 5,000 one-row MBeans, we would transfer 100 50-row MBeans from the main servers. This produced a factor of 3 improvement in network bandwidth and over a 10x speed improvement in being able to transfer that data. So 3 times less data and 10 times faster. So that just gives you an example of the significance of using tabular data. And here's an example of a display showing thousands of those MBeans that came from that type of system. So the third thing I want to highlight is pluggable transport mechanism. Right? It's important to separate your monitoring data structures from the transport code. Okay, a lot of times people are a little concerned about JMX because there is a certain transport, a TCP port that exposes the data. And what we recommend is when you design these modules to monitor your app, you basically structure it in a way that you've separated the monitoring data structures from how it's transported. So basically, in-memory monitoring data is stored in a uniform fashion, but then that becomes an input to the transport mechanism. In other words, you collect the data, put it into some in-memory tables, and then have a pluggable mechanism for transporting it. Now, it sounds simple, and of course you would want to do it, but in practice, most people don't do it and they don't think about it. So we're recommending it here. We're saying use the JMX Data Model, in other words, the simple types and the tabular types, and the transport can be anything. So the simple data model is important, but the transport could be a log file. You could construct that monitoring module to collect the data using the JMX Data Model, but then write it out to a log file if you want it. That would be one way to modularize the monitoring. Another way is write the same data from those internal tables out to a database, or send a JMS message. ... What this means is that as long as you have a uniform representation of the monitoring data that you've collected, and it's compatible with JMX, you can expose it with JMX, but you could also have a pluggable transport that would write it out to a log file, a database, or a message. So the idea here is basically you've got your monitoring code, these different modules, and we have these pluggable transport mechanisms. So there's the standard JMX API, there's a SQL interface that you might write a database table, a JMS interface, but it doesn't change these modules that you produce. And to me, this is one of the most significant benefits of understanding the JMX model, isn't to use the JMX transport necessarily, but to structure the monitoring in an abstract model and then transport it in a way that is appropriate in your world. So there are some things that you don't want to do, and I mentioned earlier making sure that you identify the data. One of the things we see people always forgetting is to put identifying index data into the data itself. And part of the reason for that is that once you collect that data, you often want to merge it with similar data collected from maybe a different system. And if you don't identify it when you collect it and return it to your system, then you're going to be tasked with the job of adding identifying information on it in order to merge it with other systems. And a simple example of that is we've seen MBeans that get produced where there's no indication as to what the server is that it came from. or the particular topic that it's measuring. And then the query is made, but you have to add that information in yourself. So we recommend making sure that you have index columns in your data. The other thing people like to do, it's very common, XML was really popular a few years ago. People realized, of course, it has performance implications. In JMX, we see tons of JMX beans loaded with these XML strings that have to be parsed. What does that do? It puts more of a burden on the consumer. You have to get the XML string from the JMX bean, and then you have to parse it. Much better if you have it already parsed and you just produce it, put it out in those simple data fields that are available in the JMX MBeans. It's a much better way to do it. We also see the key mechanism. When you reference beans in JMX, there are some app servers like WebSphere and WebLogic where you've got probably 15 individual components to the key, and the key contains the version number and all this other stuff. Now, you can understand some reason why that stuff would be there, but it complicates it. And in most cases, we find that if you include that information in the data itself, you don't have to specify it in the key. So you want to keep your keys simple. Another problem is you have a key that references data and then have in the data itself an index column that has either a same name but it has a different value in it, or they don't match in some way. And that just causes complication on the receiving end. So you want to be consistent and have any keys that you use to reference the data also be the same names and same pattern and same convention as the data that you put in the returned data. So that covers some of the key concepts. I hope that the combination of some of the example code, which would be available on our website, along with this PowerPoint, which we'll also make available, could be helpful to you. And we're certainly open to any discussions about ways we could help you instrument your apps with JMX. I'm a great fan of JMX. So with that, let's open it up to some questions and answers, or some questions, and I'll try to provide some answers.
Thank you, Tom. If anybody has any questions, you can submit them via the chat window on the right-hand side of your screen or through the Q&A. At this time, I'm not seeing any questions. Our hope was to keep this to a half hour, so it doesn't look like we're going to get any follow-up. If you do have any follow-up questions, please feel free to email me directly at gianna@sl.com, and we'll be happy to get you an answer. Oh, I'm sorry. We do have a question. When should you not use JMX?
Well, that's a good question. Now, keeping in mind that what I was emphasizing here was the abstract nature of JMX. What we're recommending here is the JMX model for monitoring. And so I would say, in the simple sense, that abstract monitoring model applies in almost every case I've ever encountered. Right? There is applications are typically composed of some kind of application manager, and then there's lots of individual components that are being managed within that application. And if you structure the monitoring to mirror that structure, you create a system that has the modularity that will allow you to maintain your monitoring and to make it independent of the app and to provide those pluggable transport mechanisms. So from that perspective, I would say the model is almost always relevant. What might be meant by that question is, when would you not use the JMX transport mechanism? And there are a number of cases where you might, for security reasons, not want to expose. Now, JMX does have, login and password, so you have to have a secure connection in order to get the data, but it's not very secure, and it can be circumvented. And there's also, because you're exposing the data on a port, it means that you would typically have to connect to your JMX server, and you may have firewall issues. In that case, it's not appropriate. Now, there are several transports in JMX. You also have an RMI mechanism. So depending on your environment, typically the areas where it's not appropriate have to do with environments that have high security and limiting access to the standard JMX transport mechanisms, in which case this notion of a pluggable transport mechanism gives you a way to expose the same data structures, but through a mechanism that you can support. And in many cases, sending the data rather than requesting the data makes more sense. So sending a JMS message from inside the firewall to somebody outside the firewall is often permitted, where the other way around is not. Hopefully that makes sense.
Thank you, Tom. One other question. On a security note, is it possible to encrypt, decrypt MD messages authorized using ACS roles, etc.?
I would say yes, that would be possible. But here again, I would probably not rely so much on the standard JMX mechanisms there. I would probably build that kind. If you're looking for that kind of security, I would probably be considering managing the transport in a fashion separately, just because you'll have more control and more flexibility in how you configure and manage it.
Okay, thank you. Is there any additional questions? Yeah, I'm not seeing any. Thank you so much for your time. We'll be sending out the slides from today's presentation, as well as a recording of this webinar will be made available for download. I'm sorry, we do have a few more questions.
Oh, okay.
One other question, is JMX growing in a way that it becomes more abstract?
I would say there that JMX has reached a certain level of stability, and one of the things that concerns me a bit is that as there's been a lot of growth around web services and other ways to transport information, that JMX has kind of been lost in the shuffle. And so improvement to JMX, we're not seeing a whole lot of new features come out. And what concerned me a little bit was some of the more complex features, the dynamic M-beams and all of this, which, while it's very useful, detracts from that abstract data model and the simplicity that I personally prefer. So I wouldn't say necessarily that there are improvements in JMX that would be moving in that direction. I think that the core of what JMX has in it right now is very sound and solid, and taking advantage of the simpler aspects of it is more than adequate for most applications, and you're better off staying with the tried and true simple stuff rather than take advantage of a whole lot more complicated stuff. That's my own personal belief, for better or worse.
Okay, that's great. Thank you so much, and thank you for those great questions. As I was saying, the slides from today's presentation, as well as the recording of this webinar, will be made available for download. I'll be sending out a follow-up email with a link to the recording within the next few days. Also, if you have any colleagues that you think would find this webinar helpful, we'll be having the same webinar tomorrow morning at 8 a.m. Pacific Standard Time. Thank you again for your time, and thank you for joining.
Thank you.